The marine engine turbocharger consists of mainly two parts, the blower side and the turbine side. The turbocharger consists of a single-stage impulse turbine connected to a centrifugal impeller on the other side through a shaft. Both the sides are provided with a casing which carries turbine and blower. The blower side casing consists of filter to suck clean air without dust or particles which may damage the compressor blower blades. A diffuser is provided in the blower side for increasing the pressure of the sucked air. In the turbine side, an inlet casing is provided which directs the exhaust to the turbine blades. It also has a nozzle ring to convert the pressure into kinetic energy before hitting the turbine blade. The shaft is carried on bearings, which helps the turbocharger to rotate at extremely high speed of about 5,000 to 10,000 rpm, depending on the size of the turbocharger. The bearings are usually ball and roller type. To know how the lubrication of turbocharger bearing is carried out, please watch our video. When the engine is started, it compresses and burns the fuel. Some of the energy gets wasted and produces exhaust gases, which needs to be drawn out of the cylinder using an exhaust valve. These exhaust gases from each cylinder go to an exhaust trunk. The turbine is driven by the engine exhaust gas. The exhaust gas from the trunk enters via the gas inlet casing of the turbocharger. The gas expands through a nozzle ring where the pressure energy of the gas is converted to kinetic energy. This high velocity gas is directed onto the turbine blades where it drives the turbine wheel. As the compressor is connected to the same shaft, it also rotates the blower at high speeds. The nozzle ring converts the exhaust gas into kinetic energy. It is fabricated from a heat-resisting polychrome nickel steel or a pneumatic alloy which can withstand the high temperatures and be resistant to corrosion. The turbine side outlet is connected to the exhaust uptake pipes which leads the exhaust gases to the ship's funnel. On the air side, the air is drawn in through the filters. A felt cloth can additionally be put on top of the filter for additional filtration. The air enters the compressor wheel axially, where it achieves high velocity. While exiting the impeller, the air goes out radially and passes through a diffuser where some of the kinetic energy gets converted to pressure energy. In the end, the air is then passed into the volute casing where further energy conversion takes place. The outlet from the blower side is supplied to the air cooler arrangement on the ship's engine. The arrangement is a shell and tube type air cooler where seawater or fresh water is passed inside the tubes as a cooling agent to reduce air temperature. This cooled air is then supplied as fresh air inside the scavenged trunk of the engine, from where it takes the supply of combustion air through scavenged ports of the liner. During the start of the engine, the turbocharger is also standstill. Hence, no fresh air is supplied to the scavenged ports, which is essential to start the combustion. Hence, additional blowers are installed which are switched on during the start of the engine. When the RPM of the engine reaches a range where turbocharger supplies fresh air, the blower is cut off.